Hello Math 2 students. Today we're going to go over graphing absolute value functions. So first we're going to start out with what we call the parent function, okay? So in order to graph this, let's go ahead and we're just going to plug in some values, and see what we get out. All right, so if I were to plug in a -2 to the absolute value of x, which is the parent function of absolute value functions, if I do absolute value of -2, I get a +2 out. If I do absolute value of -1, I get a +1 out. If I do absolute value of 0, I get 0 out. If I do absolute value of 1, I get a 1 out. And if I do absolute value of 2, I get a 2 out. Okay, so if I were to go and plot this, we get -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So absolute value functions, you get this, essentially this V shape, all right? And it goes off into infinity like that, okay? Now, the way that we graph these are very similar to graphing quadratic functions. If you recall, with quadratic functions, we have like ax minus h squared plus k. And we find the vertex, right? We find the vertex by taking this guy, switching his sign, and keeping the sign of this. So like, for example, we know that like if we had this, right, to find the vertex of this quadratic, we'd switch the sign of the 6, keep the sign of the 5, and our vertex would be at -6, -5, okay? So that's what we did before. We're going to do essentially the same thing with absolute value functions. So the quote-unquote vertex is going to be where the pointy part of the V here, okay? And if we look at the parent function, we can see that this guy has a slope of 1. This guy has a slope of -1, okay? And that's going to ring true as we go through these problems. All right. So let's go ahead and try this guy. Let's find our starting point or our vertex here. So we switch the sign of this guy, keep the sign of this guy. So we're going to have 4, 5. All right, so we switch the sign of the -4, keep the sign of the +5. So we're going to go to 4, 5. Now, this guy doesn't have any numbers out in front. So what that means is that our slope is going to remain 1 and -1. So we got a slope of 1 going in this direction. Oops, that was kind of bad. There we go. And then we have a slope of -1 going in this direction. Okay, so that is how we would graph something like this. Now, if you look at this one, all right, think about his vertex. Switch the sign of this guy, keep the sign of this one. So we're going to do -2, 2, -2, 2, and then we're going to give it a slope of 1 this way, and then a slope of -1 this way. All right. So hopefully not too bad. You can see all we're doing right now is just kind of moving this graph around. Okay. Now, both of these guys had nothing out in front, right? There was nothing there, nothing there. So that means that our slope stayed 1, and it stayed going up like a V. Okay. Now, for this one, we're going to find our vertex the same way. It's going to be -4, 4, all right? And we're going to go ahead and plot that, -4, 4. However, we have this negative out in front. So what that does is it reflects it. So instead of going up and up like this, we're going to go down and down. So this guy's actually going to have a slope of +1, this guy's going to have a slope of -1, and it's going to go down like that. All right, so that's our reflection, which makes sense, right? We've learned that with quadratics, instead of going up like a cup, we go down like a frown when that number out in front is negative. Okay? All right. You know what we're going to do to make our lives easier? I want everyone to erase this negative I have out in front here. Let's just pretend that's a +2. So everyone right now on your notes, change that to a +2 because that's going to make this problem a little bit easier for us. All right. So now let's go ahead and find our starting point. So if we see there's nothing inside of here, so if there's nothing inside of the absolute value, the x value of our vertex is 0. Then if we look on the outside here, we've got a minus 1. So our vertex here is going to be 0, negative 1. All right. Now, and remember, we took our negative away just to change the problem. This guy has a 2 out in front. So what that does is that causes a stretch. So instead of this graph having a slope of 1 and negative 1, it's actually going to have a slope of 2 and negative 2. So we go over 1 up 2, over 1 up 2, and that is what our graph would look like. And then give our slope of negative 2 here, and we get that there. Okay? So that is what our function would look like here. All right? Now let's go ahead and try another one. So our starting point here, our vertex, is going to be negative 5, negative 5. Then we can see that we have both a reflection and a stretch. So it's going to go down like a V, and we're going to, instead of having a slope of negative 1 and 1, we're going to have a slope of negative 2 and 2. So this is what our graph would look like here. All right. Next, our starting point here, we're going to have 4, comma, and then there's nothing on the outside, so that's 0. So our starting point is going to be at 4, 0. Then again, we have a reflection and a slope of 2. So it's going to go down, and it's going to look like this. Awesome.